I will ask it today because I don't know if I will be able on Friday to do the questions.
Okay. Not saying we'll have the answer.
I know, I'm sure that you will have the answer. Are we on with the reading because I can ask the question?
Yep.
Well, one of the things that we were looking is that as I found out with the simulator, that it was a very good tool. We are trying to implement a way to replicate the lawn tractor in a smaller tractor, like a robot kit. I don't know if I'm explaining me as well as you need. So we are trying to get the engineers that are working with me some little robot kits to replicate the robot as a second step before using the simulator. I'm not sure if I'm being clear about what I'm saying, but if you don't understand or you get confused of my English, just tell me. So one of the things that I was trying to replicate was the two things: the directions, because in little robot kits that it's solved because the wheels are electric, so they get the direction with the wheels, the back wheels, and the other thing was to get the sensors of the wheels that give the odometry, get some similar sensors so I can replicate that that gear that we put in the wheel with a plastic gear. I think that I can do it. That won't be difficult, but I'm yes, like that, yes. But the thing that I wasn't sure how you solve it, because I see that you have prototypes, was the steering wheel. Because because I want to put the potentiometer like I have to try to replicate that. I don't know how you solve that because I saw you have some prototypes. That one question is how you solve the steering wheel. The other question is how did you solve because I want to be as accurate as it could be, the actuator that moves the forward that moves the tractor forward. So I want to try to replicate it with a little actuator that moves the motor, the electric motors that pull the wheel. Because in all the setups that we have the same kind of actuator or situation that something moves something to push forward or backward the tractor, because we all have the hydrostatic transmissions. I'm being clear?
Yeah.
So I have, I want to ask you, how do you solve the steering wheel in your prototype? How you if I'm right of trying to replicate all that kind of shifts in the tractor, in the little tractor, and if you use the Ubiquiti image to do that.
Yep. Those are really good questions, and John Lee has been going through it. So I have a small little desktop robot, and this is using the Ubiquiti image on here, so the software is the same. The way that the
Yes.
wheels work, this is just a crazy wheel, and so it's a differential. So this drives like a differential robot,
Yes.
and that's okay. The way that, now you don't have to follow this. The way that I think about it is like levels of complexity. So with this robot, basically we're learning how to send a PWM command to this motor controller to drive the wheels, make the wheels go forward, backwards, um, it's okay that it doesn't have the motor on and off function that you'll add later. If you learn one system, then it's like transfer knowledge. If I can control a PWM here, then it's very easy to send a PWM command to your steering motor. That's controlled with.
Okay.
So you just kind
Okay.
of
Okay. But
learning the principles.
yes, I'm going to do that because I have that robot to do it. One of the things that I'm not sure about it is that I use the plain Ubiquiti image to work with that robot, the plain Ubiquiti image,
Well,
or
you
I have
need
to
to.
modify.
Yeah, you have to write a driver node, basically a node, a ROS node that listens to command velocity messages that you're sending in with the
Okay.
joystick, and then sends the
Yes.
message to this controller from the Raspberry
Okay.
Pi. And there's
Okay.
a really good tutorial on how to set up. If you follow the tutorial, it will teach you how to make that node. And
In
then
Ubiquiti, is that tutorial or at Ross page?
no, it's like my first robot. I can post it in here.
Okay.
And John Lee, feel free to jump in and give your opinions if you have a better idea.
Oh, Matt, I think your tutorial and direction is perfect for beginners. So yeah, just follow the tutorials and play with it. I think it should be okay for the driver load.
Okay. Okay. But Matt, what do you think about the reasoning that I'm doing about the second step to try to replicate the tractor in that little tractor? Is it possible, or is it, or I will be wasting time?
That's a really good um, question. So there's like we call it diminishing returns. How much effort is it going to take you to build an exact model on something like this? And then what's the value that you're going to get out of it? I can tell you there is a lot of value to building this robot and just learning how to make a driver node, how to send command velocity messages in a very simple system, because it's your robot's going to get extremely complex. So if you just do a couple little things, one, learn how to send a PWM command, learn how to control your robot motors, and then if you wanted to, this this is just basically like a pickup sensor, exactly like the wheel encoders that you have on
Yes.
your
Yes.
bigger robot. And those just
Yes.
go right in the back underneath here. So
Yes.
then that's pretty cool because now you're driving a motor and you're reading a sensor. And I think those two
Yes.
skills uh, is a fair amount of work if you're just learning. And then basically that's all robots are. Like you said, whether you're turning a motor that spins like this and then measuring a wheel encoder or a potentiometer, or you've got a shaft that's going in and out and you're measuring the results in another place. But there's kind of that two things. You're sending a message to a motor to turn on or to turn, and then you're reading a sensor to say, okay, how far did you turn? And with this robot, you can do the full example. You send PWM commands to control the motors and then read that little turn sensor, which is exactly the same setup system that you have on your bigger robot.
Okay. 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 Maybe uh, I I'm not sure that I'm uh, I was trying to find another path through here, through the robot. The, I understand that, and I think that the learning curve of that is something possible and achievable with the knowledge that now I have from the tractor. But one of the things that I'm trying to do is that somebody that do not have the tractor and wants to help uh, try to build something that is more likely like the tractor
I see.
to end. Maybe I understand what you are saying, and I consider it as a first step. But once that's done, I think that the other step that he needs to do is to work with that, with the thing that is more similar.
Yeah. What the answer? What the kind of the answer that you're supposed to give in robotics is the simulator. So if your simulator is accurate model, at least in the command and control and moving around, then you can test your software in simulation and then move it down to your robot and your robot will drive.
Okay. Okay.
That
Okay.
takes a little bit of work to learn how to use Gazebo and get everything set up. We can get a tutorial
No, yes,
from Alan.
I learned I learned that and I understand what you are saying because I think that was one of my errors not to put more time in the gazebo. And when I begin working in gazebo was when I get the most achievements in my work because it was easy to translate to take from gazebo to the robot. It was easy, but people want to get the robots, and I understand that too. so, sometimes it's a thing about getting a path to them to achieve that.
Yeah.
So when they ask me, I tell, yes, you can do it, but it's better if you learn to use the simulator. And the simulator is much easier now with the last image of Ubiquiti, with all inside and the VNC when you're using it with the Firefox or the Chrome, it's much easier than before.
Good.
But I don't know. It was a question that I need to ask.
Alan's probably done the most work in simulation. He may have an opinion on that.
Yeah. Hey, good evening. Yeah. No, I don't. I don't know how to answer that question. I'm not there yet, Matt.
Well, you have a pretty awesome simulation environment, and it's cool to see your robot in there moving around.
Yeah, I'm stuck though again now.
It's not easy. Matt, do you solve the video for the Ross conference?
Hey, we're open. It would be super cool to get some videos up and show some demos. So we've got time, but definitely.
What you were thinking about the demo? Only the robot in the
Well,
field?
yeah. Oh, yeah. Yep.
Or you want something to show up the console or the terminal showing the work of Ross?
Well, there's a Nav2 group that's working on navigation with ROS2, and it'd be fun to be able to do some demos with them. If we have an outdoor robot that's running, then you know, we can play around, and I don't know if it's possible to do, they can run the software and then control your robot in the field down there. But that's always kind of a fun demo, you know.
Yes, but you need to put internet in the middle of the field, and sometimes that thing doesn't work.
So
And get video from that transmission.
maybe not video, but at least odometry. So in RViz, you can see it moving around, and then
Yes, yes, yes. But sometimes I will try. Uh, I will try now that I have a robot outside. Uh, I will try to work in it. I'm not sure if I have a big problem. Uh, the only thing that is good is that I have all the spare parts. If I broke something, I can rebuild it now because I have the Tensi and the Citron board that will let me rebuild it. But I'm stuck.
thanks for the update. It's cool. Glad it's moving along. Glad you're adding to the team.
So Juan, the other good thing is you don't have to do you can record the video, so you don't have to do the live feed. You wouldn't have to have live internet to the middle of your field. Just record it ahead of time, and
Yes, yes. The first time I understand that, but now listening to Matt, I understand that he wants to give live video.
No, you can
First,
do
we will
recorded
try
video.
to get the robot, and and then if we are pretty confident, we will try to do the live video, or maybe we can record something similar to a live video, not so live, zombie like, and show it with the console and somebody trying to enter the tractor. Uh, I feel confident of the part of the network part to solve that, but I got to get the robot working. But I will try.
Alan, do you have an update on your progress?
no, I'm stuck. And Jeff's been helping out here, so I don't know. I posted the error message out on the Slack channel, and so I guess probably the easiest is if you want to just go look at that rather than try to talk through it. But I think Jeff's comments are on the right track. So, but anyway, my move it code is broken. It doesn't work. So something's broken in the main in ROS somewhere in the ROS installation. So somehow I did an update or an upgrade, and I don't know what happened. It was working a while ago, and now today it's not. So
I didn't put that error into answers.ros.org. There's a lot of Move It users there. John Lee, how's your project going?
Oh, hi, Matt. So, yeah, I was trying to join the meeting last week. It looks like the Zoom meeting doesn't work. So it's live again this week.
Yep.
For some reason, I could not log in, either use your link or use the code. So it's just, yeah. Well, right now I'm have progress is pretty slow. So for that robot, also trying to increase the torque. So right now the robots is kind of could not moving very well. So it's moving actually previously, but recently like I could not move it. I mean, I could not turning. So basically the turning left and the turning right has some issue. So I'm trying to increase the frequency actually, but that duty cycle frequency, but that doesn't help somehow. So that is one of the issue. I trying to like tap it. So previously Jeff suggested to put a tap on the tile, but that doesn't work. Like it could not move forward even. So
Too slow.
yeah, like left turning doesn't work very well. So I'm still figure out that problem.
Take off 2 of your motors and put on one of those.
Yeah, I didn't try that yet. So
Actually, you don't even need a wheel. You just need something like round that will slide on the ground.
oh, I have that caster wheel. I have that wheel, but
Yeah.
I happen to have 4 wheel. Like that's why I put 4 wheels there. Like basically, I put the 2 robots wheel to get into one robot.
Yeah.
So it's time to come back, in your opinion.
Yeah. If you tried it and it won't work, and
Sure. Yeah. Yeah, probably that's an easy fix.
there's a pretty good reason why it won't work. It's pretty well understood, so it makes sense.
Yeah, previously I thought that this cast wheel is kind of has an omni direction, right? So I'm afraid that it will not control the direction very well. That's my first impression.
Gotta try
Did I
it.
try? Yeah, probably I should come back to it. Yeah, that's a learning curve.
That happens a lot
Yeah.
with robots. You try something, it doesn't work, try something else.
Yeah. The good thing is that with this kind of robots, you can kind of very easy to play with. If you have a kind of big one, then you need to go outside, pull back. If something doesn't work, you need to kind of, it's difficult to deploy and retrieve. But this one is pretty neat. Like you can play very easily. I think that's very very good. Yeah, did out trying to maybe next week I can have some updates. Trying to figure out. You're stuck here for a while. Oh, Matt, what did you do with your robot? It looks like you just showed the robot is quite different. You put some extra computer there, or you just made some new structure on it? The one you just show up, or you
Yeah,
have
this one.
right?
That's the same one. Just a Raspberry Pi, a little motor controller, battery.
Oh, I see. You have a transparent box. That's why I confused.
Oh yeah. That
I
Raspberry Pi.
I see.
Yeah, really easy to test and kind of fun to play with. You don't have to go outside, so if it's raining, it doesn't matter.
Yeah. A lot of to learn, I feel.
Jeff, did you make any progress this week?
Well, I wasted quite a bit of time, but I did get something that is working. And I found out the board that I bought was a 12-bit converter, not a 16-bit, but it does seem to work fairly well. I went over to Micro Center today and they had a line way out the checkout counter. I counted as I went up, there's 39 people standing in line. So I didn't buy the new board. I was gonna buy the new board and some header pins, because they've got ones that are long on both ends. But I decided I wasn't gonna stand in line for an hour trying to check out. I was risking my life going out in the first place, and then I went in this place and this girl was trying to help me find these things because they're scattered all over the store. And I said, so why is the checkout line so long? She says, oh, it's always like that unless you come in at 10 o'clock in the morning. And it didn't used to be that way. So I don't know if it really is that way every day or what. Maybe that's the only place people can go now that they're not supposed to be going out. So anyway, what was before I started complaining about that? So I ran into all kinds of problems trying to get this stuff to work. And one of my Arduino Nanos, turns out the I2C doesn't work, but I didn't know that until I tried various other things. So I got the converter running. And I guess, let me see if I can do this. First of all, what I have right now, this is my gyroscope that I'm playing with. It's some automotive grade part, and then it's connected to, there's just an Arduino Nano. And then this board here is the A to D converter. That happens to be the 12-bit version. So let's see, I was gonna try to do this now and see what happens. Screen 1. Okay, so I assume you can see that's the plot thing on there. So if I reset the board, and then you'll notice it won't let it auto scale here. I don't know if you can still hear me. I've got the camera pointed down, but so that right there, that's one count of the ADC coming out. But if I tap on the table, you can see it. See, the gyroscope's pretty sensitive, so it understands that. If I take the gyroscope, move it, and the green line that's making, that's the integrated position of the thing as I move it. If I come back to 0, that should come back to that 0 line in the middle. It doesn't. That's the problem I was complaining about the other day. So as I move this, it comes up here. Now, let me reset it so it's back to 0 again. So what I was explaining is that in order to test it, see, the gyroscope's laying on its back, and if I rotate towards me, lay it on this side and look at the plot, and that goes out to like minus 35,000 counts or something. And if I roll it back, then it comes back. It's supposed to be at 0, but it went too far. After I roll it the other direction, it goes around, I can't remember what the number was, 42,000, I think, and roll it back. And theoretically, that it should always come back to 0. And I decided, see, there's anything else I need to show there. Let's see, what was I just talking about? I have a camera won't mount. Well, maybe you just won't see me. Here, I'll try that. Okay. So what was I talking about? The gyroscope. Oh, so I did that experiment. It looks like it does. The direction of it does seem to give me a different value depending on if I'm going forward or backward with it. And so I put in a scale factor to fix that, and it made a difference, but it didn't really fix it. So that may not be the problem. The other thing is I should have a precise time base. So I'm reading this at exactly, say, 10 milliseconds or 100 milliseconds or whatever. And right now I'm just using the standard thing that everybody does on an Arduino. You say read it and then wait X number of milliseconds to read it again. And so that's not real precise. And the other problem is in between I'm printing out stuff on the serial port. And let's see, let's kill this. Bring up serial monitor. Go back to sharing. Screen 1. Oh, you're not going to be able to read that. Let's see, how do I make that bigger? Well, maybe you don't have to be able to actually read it, but if you watch, as I turn it one way, those are all positive numbers, and the third column has like a 5-digit number it's making. When I go the other direction, see I got a negative signs that are popping up. And if I come back here and go this way, I eventually get all 3 columns have negative signs. So just the number of digits that is printing out is affecting my timing loop. So that might be part of my problem right there. So I tried to go in and try to use the that Arduino, what do you call it, timer 1 library, I think they call it. And you load that up and you say, create a time base of every 1,000 microseconds, call this interrupt routine. And that was working when I was trying to just use the built-in A to D that's on the Arduino. But when I try to run it with this thing, it won't. When I try to talk to this board, it just locks up and won't do anything. So I don't know why I can't put this driver code into the interrupt routine. So I was gonna try to track that down tonight. So I went out and looked, and I found somebody on I think the Arduino answer group was asking exactly the same thing I was. They said they want to be able to, they want to use this chip and sample it at a constant rate, and they were trying to use the built-in concept where you can say put it into continuous mode, and you say sample every X number of milliseconds, and then when it's done, it'll raise the interrupt pin. There's an interrupt output pin, and they're trying to get Arduino to read that. And in talking through that, the guy had rewritten the library enough that should be doing what it needs to do. And after a couple of interactions, they got it figured out and made it work. So I'm going to try that now. So that would, if I can get the board itself to do the to continuously sample at a constant rate and interrupt, then I can just read the numbers out, and that'll take care of the problem. I don't have to worry about my serial interface affecting the timing rate, and it's going to be running off the interrupts, so that should work. And back when I was first showing that graph, and I said what it showed at 0 was just occasionally just a little blip. If I tap on the table, I get some numbers popping up there. That's showing that it's pretty noise free. And the other thing is, if you got a MEMS gyroscope and you fire it up, it says, okay, your speed is 0 or your output is 0, and you just let it sit there for a while, and that starts drifting up to 5 and then to 10 and to 20. And I think it's all based on temperature. It almost seems like you just look at them and it starts drifting on you. This one I can run for hours and hours and it doesn't move at all. So that's a good sign. So I'm going to try to get the A to D running correctly, and then try to get to the point where if I turn it right and then turn it left, it comes back to the same point. If I get past that, then I'll have some more information on that. So I guess that's pretty much where I'm at right at the moment.
It's progress.
And then what I should do when I get this running is get one of the little MEMS gyroscopes, put them both on the same board, and either walk around with them or put them on the robot, drive around, and see how they both act together to see what that does.
Chef,
Yes.
where are you thinking that you're going to put in the robot the accelerometer?
Well, it's a gyroscope, but I'm just going to put it on wherever is convenient. I'll probably bolt it on the top because it measures the rotational rate of the vehicle. And this happens to be a single axis. In fact, on the side of it, it's got the little sticker on the side, which there it is. So it was pointed up like this, and it measures the rotation in this direction around it. So if I just bolt it on there somewhere, so I can just measure the thing as it turns, and if I'm going straight, it should say I'm going straight, and so forth. So this is just like one piece out of a full IMU, where a full IMU will have 3 gyroscopes and 3 accelerometers and 3 magnetometers, and they mix all that together. Right now, I'm just playing with a single axis gyroscope to see if I can get valid data out of that and make it do something useful.
Okay. I was asking because last month I bought 2 accelerometer for Arduino to have it in my lab and I was leaving it for the future because I thought that was something that I would need to put in the robot. That was why I was asking where you were thinking to put it.
And it's just a matter of bolting it onto the vehicle somewhere. So it's just measuring the overall action of the robot itself. So as the robot's driving down the road or driving down the field, you know, if you're turning left and right, you should be able to measure that. And the accelerometers can look at the, say the as the thing goes over bumps, you should be able to see the acceleration from that. And theoretically, if you turn, you get some acceleration value out of that. And I'm not sure how useful most of that is, but I know the gyroscope, I've played with those enough in the past that I think that if I can get one that's stable enough to give me nice looking results, I think I can get, I'm able to do something interesting with it. So I'll have to play with that and see. And if nothing else, I can take this gyroscope, which I think is working better, and just replace the Z-axis accelerometer in my big IMU or my normal IMU. So instead of using its value, I could use this value. So I could use everything else that's on the normal IMU, feed this value in, or I could run them both at the same time just to get multiple sources of information. And then speaking of IMUs and magnetometers, something else occurred to me that when I was experimenting before, and I probably wouldn't be able to pull this up quickly. Wait, maybe I can. Anyway, I was driving in my front yard, and as I'd go around a loop, and as I would, I'd get to a certain point, and I saw the compass. I had a compass module on there at the time, which is essentially the same as a IMU, magnetometers in an IMU. And every time I go past a certain point, it would turn a little bit one direction or the other. And I don't know what was causing that. I don't know if it was something buried in the sidewalk or something buried in the ground. So I got to thinking about what could you do with that. That's where it's at.
Se te va a caer la tablet.
Well, I thought I could pull this up here, but maybe not. Let's see. What's this one look like? Here's an example. Let's see. Share screen. Screen one. This is when I was out driving in my front yard, and down here is the corner of the sidewalk where I've got the 0 placed, and the blue line is what the odometry thinks I'm driving. So the odometry thinks I'm driving a straight line, but the green line is when I was doing gyroscope experiments. So what really happened was, I think the green line is really straight, and the blue line should be coming over here somewhere. Because then when I was done, I would drive back from the point down here back over where it's supposed to be. So anyway, that shows you can compare the two different paths right there to see which one is actually correct. And I think this is the right directory I'm looking in. Let me find. This one, I think. And let's see, can I zoom in here? So this is the one I'm thinking of here. So here again, I was driving in my front yard. This is the 0 down here is where the corner of the sidewalk is. And I would drive up north here to this point. It's bigger. So if you look at the blue line comes up here. That's my odometry, and then I turned left. I went over here to a point in front of my house, and then I drove back to the original starting point. And the red line is I was taking the compass value as a heading and taking the distance from the odometry. So as I was driving north here, you can see the red line is veering off a little bit to the left, but right here, it gets to a point and all of a sudden it veers off to the right. And I've got another plot, which since I didn't have the stuff pulled up ahead of time, it'd take me too long to find, but I had one where I run around 2 or 3 times, and every time I go around, it would change at that same point right there. So there's either something in the ground, because if I look at it, it's just the sidewalk and nothing else around, but there is in the house, from right about here on the house, there's a water line and a sewer line that runs out here into the street. But I figured those were low enough, they shouldn't affect anything. So I got to thinking about if you were to put multiple magnetometers on your vehicle, or just put one magnetometer. If I just run this experiment, this is way before Ross when I was doing all this stuff. So if I just put it on there and drive this path again, you could even just drive some kind of a a crisscross pattern across here. And theoretically, if there's something in the ground, you should be able to see the pattern, will form around where the magnetic anomaly is. So that would be interesting to do. And then I was wondering if you put, say, a magnetometer down low, one that's close to the ground, and put another one that's stuck up on a post, you might be able to determine, um, as you drive around, you can decide, is it something in the ground or something somewhere else? And you can determine if the one that's up above is going to give you better readings than the one down below, just in general. And I got thinking, well, what if you put one on the front and one on the back? As you're driving along like this, you drive into a magnetic field, the one on the front's going to turn and the one on the back won't. So theoretically, whatever the distance between the front and the back is, then when you get that far ahead, then the back one should turn also. So I was just thinking about different ways you could actually track that magnetic field and maybe do something interesting with it. And I'm sure there's enough, because in behind my house, well, here, let me pull this up again, since I've just wasted everybody's time anyway. So in the back of my house, right here, there's a chain link fence that runs along here all the way across the back. And then there's an air conditioner sitting here and an air conditioner sitting here. And so if I drive past those, I'm sure the chain link fence will screw it up, but I don't know without going out and trying it. So that'd be an interesting experiment. And if I drive past cars, which I don't know if I have any cars in the picture here, but they had a school bus parked there as well, the little short school buses that the neighbor had. And I'm sure if you go past something like that, that would screw it up. So it'd be interesting to find out what those things are going to do just by watching the magnetic fields coming out and determining if you can do anything with it. And another question, I don't know if anybody's played with this, but if you have a magnetometer or something, like I know the gyroscope and the accelerometers always have multiple sensitivities you can set. They'll say the accelerometer is like 1, 2, 4, 8 G's or something. You can pick the range you want to set it at, and the gyroscope is usually like in 100 degrees per second or 200 or 2000 degrees per second. I'm just wondering if the magnetometer has a setting like that. So I'm wondering if you just set the sensitivity of the magnetometer down, if it's going to ignore a lot of the stuff that screws up everything. So that'd be another thing to experiment with. Once it's running, try it. Find somewhere in the path, like right here, where it screws up. And also, it did it right there. And if you look down here, coming back the other direction, it did it right here again. So I got 2 places in that path that seem to be repeatable as I drive around. And right here, this would have actually been going through the grass right here. And there is a hole in the ground right there that's like I think it was a tree that's settling over the years. But other than that, I don't know of any metal that's in the ground. So if you could find a path like that to go around to test, and then maybe change the sensitivity of the magnetometer, it could be that if you set the sensitivity down, it's, the Earth's magnetic field is still strong enough that you can pick it up, but the stuff close by won't affect it. But that's just a thought.
What can I ask a question?
Sure.
Somebody knows about if the magnetometer can you measure conductivity?
Conductivity of what?
Of soil.
I doubt it, but I don't know. If you got something in the soil, if you got a lot of iron in the soil, it would affect the magnetic field, but I don't think it would. I don't know.
Okay.
Now they have things like the mine detectors, or the treasure hunters use these things that you run across the top of the ground. If you see a coin or a nail or whatever in the ground, it reacts. But that one's actually I think it's generating its own magnetic field, and then the metal in that field disturbs it, and I think it changes the frequency of the signal or something. So that's how, like a mine detector, that's how those work. You move it across the ground. If there's something in the ground, it will detect that. But I think that takes like a fairly major piece of metal for it to do anything. I don't know if you could actually look at soil composition by doing that.
Oh, because conductivity, I don't know how they say it in English. Here we have a Veris bar that surely is in United States too, that you measure conductivity in soil, And that kind of information is very important when you are working with the crops, because when you have difference in the conductivity, commonly you have salt, high levels of salt in soil. That is one of the markers of bad productivity. So I was one of the things that I'm trying to do with the robot is take that kind of measures, because are very important, those measures. So I was thinking that maybe with the magnetometer I could get a similar uh, number, but surely I'm wrong.
No, I was working with this sensor today. It's a Bluetooth sensor, and then it will give you data of the soil connectivity, temperature, all that type of stuff. And it's Bluetooth, so you can read the sensor. And then I've been working with, are you familiar with Farm OS? Oop, not that one.
Yes.
So we're playing a little game inside of Farm OS. You can send it data. So this is Farm OS, and you can set up different assets inside of your farm. And one thing they have is sensors. So I was working on a driver between like these sensors, these Bluetooth sensors, soil monitoring sensors, and then make a ROS node that we can automatically update. So this is data that you can just send over the web, and that updates into your farm management tool. It's pretty fun. I'm getting beat. I'll show you this sensor. So if you want to see the, this is the Bluetooth sensor, and pretty simple. It already has all of the imports that you need to make it run and to pull it. So you can pull temperature, moisture, light, connectivity, and battery level. So we'll take a live measurement. So here's our current measurement. The soil connectivity is 710. I'm not sure what that means. But here's a Python problem for you guys. It has to run on Python 3 to load these libraries. I want to load ROS.py so I can publish these, and ROS.py needs Python 2.7. And it's like, I can, it works, obviously you can see it. So Python 3.6 is loading, all of this stuff works. But when I try to, I don't know how to like change what Python version. I don't know how to get it to change to this before I try to import this library. I've tried to like insert it. You know what I mean? So I load Python 3.6, it loads these. Then I tried to reinsert this at the pole position 0 and then load it, but it doesn't work that way.
That's
You just have
why
to,
we are going to all be dead with ROS 2, because
that's what I was going to say too.
I'm pretty dumb, but I can understand, as I suffer with the installation of the ROS, the difference between Python 3 and Python 2. I learned Docker to solve that. But well, it's an important thing. Maybe Docker is the solution for that. You have to make a virtualization to run that part and push the information to the other side. I don't know how to say how to work it, because you have two different versions of ROS of Python.
So I create one node and I publish those things to MQTT, and then in the regular ROS node, I read the MQTT and then publish it out to ROS.
Right, that'd work.
Is that ridiculous?
no, no, no. it's it's not easy. Uh, I I always remember because now I'm doing. I want to when they finish. I want to tell something that I'm working in too. But I remember one of the last times that I could come, that I think that was chef that tells that he didn't uh, put the importance of object programming when he was working, and later he couldn't come up, and that was why why he wanted to go with ROS 2, and that that always haunts me about ROS 2, because if chef is saying this, I'm I'm not sure what I I must be doing. It's confusing, but I understand that ROS 1 is pretty solid. I need to solve ROS 1 first to step up to the other thing. Can I show you, chef is finished?
Yeah.
Well, let me show you.
I just want to make a comment on that. You
Yes.
know what the problem is. You know that you want to run Python 2.7 and Python 3.6 at the same time. So I just did a search here, and there are other people that are trying to do such things. But since you know what the problem is, you can specifically look for that. And the very first thing that popped up, it says how to run ROS if your default Python is 3.x something. And they're mentioning various things. I do know at one point I had something that I had to run, and one of the smart guys at work said, "Oh, here, let me set up this directory." He had something that automatically switched, so when you go into a certain directory, it picked the right version of Python. And I don't know if that's what you're trying to do right now, because I was thinking that I needed 3.5 to run whatever I was trying to run, but I think it was still talking to ROS, so it seems like it still had to have the 2.7 available. But back to your question about, well, do you run two nodes that have them talk with MQTT or whatever? And sometimes you just got to do whatever works. So that is one option if you can get, and whether they're talking with that or some other kind of ROS message they're sending back and forth, that may work. I don't know. But that's all I had to say about that. So.
Okay, I'll take a look.
May I show?
Yes.
Yep.
What? Okay. What are you seeing my browser?
Yes.
Well, one of the sensors that I'm looking to work is this one, this MPK sensor. And one of the things that I wanted to do is to put in the tractor an arm that push the sensor to the earth to take the measure. I think that that's one of the best approaches that I can work, because this is a very important information for agriculture. The other thing is that I bought this company is a company from Argentina that is, I think, I'm not see yes, it's a company from Argentina that is working with IA and detecting weeds, and they have a program that we are the first or the no, I think that the second or prototype that they built, that is a Raspberry with a camera that is taking photos to build a data sets, and the data set that the program is called Know Your Field. It's like Know Your Field. We are trying to finish a deal with them that they will give up the data sets in an open format, and we will get them to GitHub. We are going to put these raspberries in the sprayers at the field, and free the information and the data sets at GitHub. But one of the things that I'm trying to do is, if I ever make the tractor work again, is to put that camera in my tractor. I will try to show you. Let me see. I'm trying to show you the no. I thought that I have it here. I want you to show the device, but well, that will be in another time. Well, that's all. I don't know. I'm not sure if you understand what I'm trying to say.
I think that'd be cool to get some field data, get some images and see what that's like. Mount that to your robot and drive it around.
Yes, I'm not sure if I can do it with the robot. Mainly, I will try to put in ROSAG because they have the data sets, but I will try. I'm not sure that I can accomplish. The worst situation is that I will get another data set in GitHub for other to try to train some machine learning on it, but it's better than nothing.
Yeah, no, that's cool. I'm glad you got signed up on that program.
Yes, no, I have to pay. I had to order machine. It wasn't free, but I'm sure that that's the way. But they are in a startup and they're in the beginning, and well, surely will help us. But
It's great. There any other topics for tonight? All right. Well, good luck. I hope that Google brings you the right pages that you need to solve the problem.
well, bye. See you next week.
All right.
Bye.
Thanks, Matt. Thanks, everybody.
Bye.